So the last way to solve quadratics is one that you're probably the most familiar with. It is the simplest, so this won't take any time at all. And it's by graphing. And this is probably the way that you got through your SOLs when you took Algebra 1. So first we're going to talk about your number of solutions. We've talked about this before. If your graph crosses the x-axis twice, you have 2 solutions. If it only crosses it once, it's 1 solution. And if it does not cross at all, it's going to be no solutions, okay? So solutions to quadratic equation are points at which the function intersects the x-axis, okay? The solutions are referred to as zeros, okay? Solutions, which is the new one, or x-intercepts, which we've been going over all year long. Okay, so the only thing that you have to do is find the solutions to the quadratic by graphing. And so we just have 3 problems here. And all you have to do is put the equation in Desmos and look at where it intersects. This will only work well if you have whole numbers. Otherwise, either factoring or using the quadratic formula or square roots is actually the more appropriate thing to solve. It's only if you have whole number factors or the solutions are whole numbers that this is actually effective. So my first equation is x squared plus 2x minus 3. Okay, and so I have my graph here. I look at it, I see where it crosses. It crosses at -3 and 1. So if I were actually asking you to do this, I would say, okay, it crosses at, picked the wrong one. It crosses at -3 and 1, and so my graph would kind of look like this. If I were to ask you to show work, I'm not too stressed out because I'm not asking you to graph, and so it would be -3 and 1 would be my solutions. Next one is -x squared minus 10x minus 25. -x squared minus 10x minus 25. And for this one here, it crosses at -5, and that's it. This only has 1 solution. Now, you don't write these as points because we're just trying to solve our quadratic, okay? So in this case, it's actually, what we're doing is we're setting these all equal to 0. And so, oh, in this case, it was -5. Sorry about that. And so that's what it would look like. And so your solution would be at -5. And last but not least, -x squared plus 8x minus 17. Okay, looks like this, and what you realize is my vertex is at 4, -1, and there are no solutions. Okay, and so my graph looks like that. And so this one would be not no solutions, but no real solutions. What's interesting about this one is this would actually not be the best way to solve this because there are imaginary solutions. So we can use our quadratic formula to actually go through and solve, going back to the previous lesson. So in this case, A would be -1, B would be 8, C would be -17 because the quadratic formula is the best way to find imaginary solutions. X is equal to -8 plus or minus the square root of B squared minus 4 times A times C all over 2 times -1. So X is equal to -8 plus or minus the square root of 64 minus 68 all over -2, which is -8 plus or minus square root of -4 over -2, which is -8 plus or minus. Now, I know I'm going to have an I here, and then the square root of 4 is 2 over -2, and I know I can divide all of these by negative 2 in this case, because I can divide by my denominator. So that's going to be 4 plus or minus 2i, and that's actually my solution. All right, I do have two imaginary solutions. I have 4 plus 2i and 4 minus 2i. But for the purposes of this, the graph tells you that there are no real solutions, and that would actually tell you